Hey guys, in this video we're going to be doing a little bit of a change of pace. We'll still be working with exponents, but in this section and the next section we're going to be learning how to graph what are called exponential functions. Okay, so we're going to be reviewing how to graph in this video. First thing I want to talk about though is what is an exponential function. So far in Algebra 1, everything that we've been graphing have had terms that involve a variable base. Okay, so everything we've graphed so far has had a variable base with an exponent that is an integer. Okay, and again, an integer is just a number. So what we've been spending most of our time graphing are lines. Okay, so now that you know a little bit about exponents, you know that a line, okay, its equation looks something like this. Here's an example of a line: y equals 2x plus 3. Okay, and the exponent on the x value in a line is a 1. Okay. Last year when we first learned about just how to graph and how to make a table of values, you would sometimes graph equations that looked like this. Okay, you might graph something that looks like y equals 2x squared, and so that would be an example of an equation where the variable is still a base, okay, but the exponent is a 2. Okay, but now we're going to be looking at equations where the variable is not the base, but the variable is instead the exponent. Okay, and so that's what an exponential function is. It's a function whose base, again that's the big number part of an power, whose base is a number and whose exponent is the variable. So an exponential function is a function whose base is a number and whose exponent is the variable. And so the most basic type of exponential function we're going to work with is going to look like this. It's going to look like y equals a times b to the x power. Okay? And so in this case, a and b would actually be numbers. So maybe like 3 and 5, that's what a and b would be. And b would be the base, and you'd be taking that to the x power each time. Okay, so this will make a little bit more sense when we see some actual examples. Okay, so right now we're doing just a lot of vocabulary. Two more things I want to talk about in terms of exponential functions. I want to talk about the different type of exponential behavior. So we have what's called exponential growth, and exponential decay when we deal with exponential functions. Exponential growth and exponential decay. And each of these different types of behavior is going to look differently in terms of a graph. Okay, so here's how you tell from the equation whether or not you have growth or decay. If your base, and again your base is going to be your b value, so if your b value is greater than 1, then you have exponential growth. Okay, and so the basic shape of an exponential growth graph is going to look like this. Okay, that's going to be an increasing graph. If your base is between 0 and 1, notice I didn't say it was negative, but I said it was between 0 and 1, which means it's going to be a proper fraction, okay, or a decimal, then the function represents exponential decay. And so decay is going to look like this. It's going to be a decreasing graph. So these are the two basic shapes you're going to have for exponential functions. Growth, which just means it's increasing, and decay, which means it's decreasing. One other vocabulary term I want to talk about, and then we'll look at some examples here, is what's called an asymptote. And this is, you notice I drew a dashed line underneath each of these graphs. Okay, that dashed line represents an imaginary line. So the asymptote is the imaginary line that a graph approaches as you move away from the origin. Okay, an asymptote is a imaginary line that a graph approaches as you move away from the origin. Okay, so now we're just going to move on to several examples, and hopefully this will start making a little bit more sense. I know right now you're probably thinking, what in the heck is he talking about? But again, this is all vocabulary. Once we do a few examples here, hopefully you'll see what I mean by all these different terms. Okay, so let's just start with the basic one. Number one, we have the function y equals 2 to the x power. Okay, so the first thing I want you to identify is the type of behavior. Is this growth or is this decay? Well, in this case, our b value is equal to 2. Okay, that's our base. And remember, I said anytime your b value is greater than 1, you have growth. Okay, so this is going to be an example of exponential growth. And so that means we can expect that our graph is going to look something like this. Okay, that's going to be the basic shape of our graph. So what we're going to do now is we're going to make a t-chart, and we are going to actually pick x values that we want to plug in to our function here. Okay, and for today we're going to be using the same 5 x values every single time. We're going to be plugging in -2, -1, 0, 1, and 2 to our function y equals 2 to the x power every single time. Okay, so that means each time I'm going to be taking the base of 2 to this power. The first time I'm going to do -2 power, and then I'm going to do the negative first power, and then the 0, and then the first, and then the second. Okay, so here we have 2 to the -2 power, and I'm going to do some work here in the middle. We know from our unit of study on exponents that 2 to the -2 power is the same as 1 over 2 squared, okay, which gives me 1/4. So when I have a -2 as my input, my output value, my y value is 1/4. Okay, then I'm going to plug in a -1 for x. So now I have 2 to the -1st power. 2 to the -1st is the same as 1 over 2 to the 1st, which is 1/2. Okay, and then I'm going to have 2 to the 0 power. We know anything to the 0 is 1, so that would be 1. Then we have 2 to the 1st power, which we know is just 2. It's nice when you have positive exponents. And then finally 2 squared is going to be 4. Okay, so these are my 5 output values, 1/4, 1/2, 1, 2, and 4. And now I'm going to graph each of these x and y values as ordered pairs. Okay, so I have the ordered pair, first of all, -2, 1/4, that I'm going to graph on this coordinate plane over here. So we're going to go left 2 and up about 1/4. Right here. Then we have the ordered pair -1, 1/2. So I'll go left 1 and up about 1/2. Then we have 0, 1. That would just be up 1 from the origin. 1, 2. That would be 1 right and 2 up. And then finally 2, 4, which would be 2 right and 4 up. Okay, and you can see that this graph right here is taking this basic shape, okay, of a sort of a J shape. Okay, and this is the basic shape of an exponential growth function. And so we're going to connect our dots in a nice curve. The first part of the graph is going to look almost like a flat line. It's going to look like this. And for all of these graphs, okay, you're going to have a horizontal asymptote. Remember, that's the imaginary line that the graph approaches. You're going to have a horizontal asymptote on the x-axis. Okay, so you're actually going to have an imaginary line on the x-axis that kind of gives that graph its basic shape over here. Okay, so that graph is not really going to touch that line, it's just going to do this. Okay, so that's the basic shape and that's the basic process for graphing an exponential function. Let's go ahead and try this a few more times just to get some practice. Okay, so for number 2 we have y equals 1/2 to the x power. This time my base, or my b value, is equal to 1/2. And if you look back at the first page, I told you anytime your b value is between 0 and 1, which 1/2 is, you have exponential decay. So this is going to be an example of a decay graph. And so we could expect the graph to look like this and be in this shape. Okay, so now I'm going to make my t-chart, just like I did for number 1. We're going to pick x values of -2, -1, 0, 1, and 2. And I'm going to plug each of those in to my function. I'm going to do 1/2 to the x power every single time. Okay, so first of all, I'm going to plug in negative 2. So we're taking 1/2 to the negative 2 power. Remember that a negative exponent means you're doing the reciprocal of the base. So this would be the same if we flip this over as 2 to the positive 2 power, which would of course give us 4. Okay. Now we have 1/2 that we're taking to the negative 1 power. Again, if we flip our base, because this is a negative exponent, we get 2 to the positive 1 power, which is just 2. So anytime you have a fraction base and a negative exponent, just flip your fraction over, okay, make the exponent positive, and then you can figure out what your answer is going to be. 1/2 to the 0 power, anything to the 0 we know is 1, so that would be 1. 1/2 to the first power is just going to be 1/2. And then finally 1/2 to the second power would be 1 squared over 2 squared, or 1/2 times 1/2, which is 1/4. So now we're going to plot these 5 points, starting with negative 2, 4. So negative 2, 4 would be left 2 and then up 4 from the origin. Then negative 1, 2 would be left 1 and up 2 right here. Here's 0, 1, 1, 1/2, and then finally 2 and 1/4 would be right there. Again, you're going to have a horizontal asymptote at the x-axis, so that's going to give your graph its basic shape right there. Okay, so we're just going to connect our dots to make this a nice smooth curve. This time this is going to be decreasing and becoming almost flat down here this way. Okay, now let's try number 3. This time we have the equation y equals 5 to the negative x power. So let's go ahead and make our t-chart for this one. Again, we're picking the same standard x values of negative 2, negative 1, 0, 1, and 2 every single time. And this time we're taking a base of 5 to the negative x power. So I'm going to put that negative sign up there just because, again, that's part of the actual equation right there, 5 to the negative x power. Okay, so for negative 2, we're plugging that in for x. So we're really doing 5 to the negative 2 power, which would actually be 5 to the positive 2 power. And 5 squared, you know, gives you 25. Okay, so just be careful. When you're plugging a negative into an exponent that already has a negative in front of it, you're going to get a double negative, which makes it positive. Same thing happens when we plug in negative 1 here. We're doing 5 to the negative 1 power, which becomes 5 to the positive 1 power, which is just 5. Okay, when we plug in 0, you can't have negative 0. That just becomes 5 to the 0, which we know is 1. Now we have 5 to the, if we plug in a positive 1, that negative sign there in black makes it a negative 1 power, so this becomes 1 over 5 to the first, or just 1/5. And then finally plugging in a 2 gives us 5 to the negative 2 power, which is 1 over 5 squared, which is 1/25. Okay, so now I'm only going to plot the points that are reasonable here. So negative 225 on this graph right here really isn't reasonable. I don't want to go all the way up to 25. So even though I'm including this in my t-chart, I'm not actually going to plot it on my graph. What I am going to plot is the point negative 1, 5, which is going to be right here. I'm also going to plot the point 0, 1. And the point 1, 1/5, which is just barely going to be above the x-axis, about right there. I'm not going to worry about the point 2, 1/25. 1/25 is just way too small to even try to plot on here. It's going to practically be on the x-axis. It's going to be so small. So I'm just going to go off these 3 points right here. As long as I know the basic shape of my graph, I'm okay. Again, my horizontal asymptote is right here. And so now I connect my points and I see that I have exponential decay for this graph. Now you may be asking yourself, well, your base was 5, why in the world is this decay? Well, here's why. Okay, in your general form for an exponential function, it has to be in this form, y equals a times b to the x power. Notice that this equation was written to the negative x power. So if we want to change this to this general form, we need to make x a positive, which means we need to take our base and we need to do the reciprocal of it, which would give us y equals 1/5 to the x power. So that's the reason this becomes a decay, is because when you write it in this general form here, your base is a fraction, 1/5. Looking at number 4 now, this time I've added something. I've added an a value in there. Y equals 2 times 4 to the x power. Really, we had an a value for 1, 2, and 3. Okay, the a value was just 1 each time. But now looking at number 4, we have an a value of 2 and a b value of 4. Okay, so again, your b value tells you whether or not it's growth or decay. This is a number greater than 1, your b value, and so that means we have growth for this one. So our graph is going to look like this. Okay, so if I make my t-chart, and plug in -2, -1, 0, 1, and 2, this time I'm going to need to focus on my order of operations. Okay, every single time I'm going to be taking 4 to my power, and then I'm going to be taking that answer times +2. Okay, so it's going to look like this. When I plug in a -2 here, order of operations says I do exponents before multiplication. So really I need to do 4 to the -2 power first. 4 to the -2 power is 1/16. And then I need to take that number times 2. 2 times 1/16 is going to give me 1/8. Okay, so always make sure you do your power first and then multiply at the end. Okay, so now we do 4 to the negative first, which is 1/4. When I take that number times 2, I get +1/2. Next, we're going to do 4 to the 0. 4 to the 0 is 1 times 2, which is 2. Next, we do 4 to the first. 4 to the first is 4 times 2, which is 8. And then finally, I'm going to do 4 squared. 4 squared is 16 times 2, which gives me 32. Again, I'm only going to plot the points that are reasonable on here. I'm not going to plot -2 1/8 because 1/8 is just a bit too small. It's really unnecessary to plot on my graph. I am going to plot -1 1/2 though. That would be left 1 and halfway up from the x-axis, so about right there. 0, 2 would just be 2 up from the origin. And then 1/8 would be right 1 and then 8 up from my origin. 2, 32. 32 is way too high, so I don't need to plot that on my graph. These three right here are giving me my basic shape. Okay, we know it's going to be growth. Again, here's your horizontal asymptote on the x-axis. And if you connect your dots in a curve, you're going to get that basic shape. It's a little bit even steeper than some of our others, but that's how it's going to look. Okay, 2 more examples I want to look at, 5 and 6, and for these I want to pay attention to what happens if I make my a value less than 0. So what happens if a becomes negative? So notice in number 5 we have an a value of -5 and a b value of 2. Okay, so this graph is still going to have growth because our b value is greater than 1, but it's going to look a little bit different than the other growth graphs we've seen. And so I want you to see how that looks here. So for our t-chart here, again, we're going to plug in those same 5 x values that we've been plugging in each time to each of these graphs. Okay, so we're going to plug in -2, -1, 0, 1, and 2. This time we're plugging them in to this function right here, -5 times 2 to the x power. So each time we're going to be taking 2 to the power and then multiplying that answer by -5. Okay, so when I plug in -2 first of all, 2 to the -2 power is 1/4, and then when I take that times -5, I get -5/4. Or -5/4 as a decimal is -1.25. Okay, next I'm going to plug in -1. 2 to the -1 power is 1/2. -5 times 1/2 is -5/2, which is also the same as -2.5. Then I'm going to plug in 0. 2 to the 0 is 1. Times -5 is going to give me -5. Then I'm going to plug in +1. 2 to the +1 is 2. Times -5 gives me -10. And then finally when I plug in 2, 2 squared is 4. and then times -5 gives me -20. So these are your 5 y values. Again, you get a couple of decimals here. Okay, the reason I make them decimals is because I think decimals, when you think about it that way, it's a little bit easier to plot on the coordinate plane. So now I'm going to plot each of these points, again, the ones that are reasonable. So starting out with -2, -1.25. Okay, that would be left 2, down 1 and about a quarter, so about right here. Then we have -1, -2.5. That would be left 1 and down 2.5. 0, -5 would just be down 5 from the origin. 1, -10 would be 1 right and then down 10. And then finally that last point, 2, -20, that's a little bit too far down. I'm not going to worry about graphing that. Our horizontal asymptote for this one is exactly the same as all the others. It's going to be on the x-axis. And this time the shape of your graph is going to do the following. Okay, it is going to look like this. It's going to be a decreasing graph. Let me try that one more time. A decreasing graph that looks just like a growth graph, but it's flipped over basically. Okay, so it does this right here. And that's because your a value is less than 0. So anytime your a value is negative, okay, you're going to have what's called negative growth. And so this graph right here would be an example of a graph that has negative growth, and it's going to have this shape right here. And basically what that means is the entire graph is going to be below your horizontal asymptote. Okay, you do have one more example on your notes, but what we're going to do is we're going to stop the video now, and then we're going to do that last example together as a class, just to get some practice all together on how you make these t-charts, because I know this is going to be a little bit different for you compared to what we've been doing for the last several weeks. Okay, so number 6, we're going to hold off on that and do that one in class, and then we're going to take a few questions over this and do a lot of practice over this. Okay, so hold off on number 6. We'll do that next time. Feel free to go back and watch anything in this video that you need to, and until I see you, have a nice day. You're all wonderful people. Take care.